Alright, we're going to work through how to do a three-step Stoich problem, doing from a mass of one substance to a mass of another substance in your reaction. So here I have, if I have 150 grams of this mercury oxide, decompose what mass of mercury is released. Okay, we're going to use this balanced equation. So we're going to put our given, again, in the top left. So 150 grams, the mercury oxide, and then I'm going to go to grams of mercury. That's my ending point. To see the three steps, what they're going to look like, we are given grams. Okay, so we're going to do the molar mass of our compound. That'll give us the moles of it. We're going to use the mole ratio step to go from our starting substance to our ending substance. And then from there, we're going to figure out the grams of that new substance that is in the reaction. Okay, so those are the three steps. So here, if I have grams on top, I need to cancel them out. Put grams HGO on the bottom. So this is going to be the molar mass. Periodic table, look at the periodic table, and that's for every 1 mole of that same substance, HGO. So to do the molar mass, this is where we separate the compound into its elements. So we've got mercury and we've got oxygen. We have 1 of each. And we're going to look up the masses on the periodic table. So mercury is 201 and oxygen is 16. So that's 201 plus 16, so that would be 217. And that number goes down there. So we cancel out. Now we're in moles of mercury. We're trying to get to, or mercury oxide, we're trying to get to grams of mercury. So we need to do some more converting. So we're at mole here. We're going to put the same substance mole on the bottom and the mole of the new substance on top, which in this case is the mercury. Okay, so mole of mercury on the bottom to cancel out the one on the top here. And then we're going to go to mole of the new stuff, the mercury. This is where we look up the, see in the question marks here, the coefficients from the balanced equation, so the big numbers. Mercury oxide has a 2 in front of it, and then the mercury here has a 2 in front of it. So that's how the number of moles involved. Okay, so now I'm in moles of mercury. I want to get to grams of mercury. So my last step here is to go from mole to grams. We're going to put 1 mole on the bottom and put the molar mass from the periodic table on top. So 1 mole Hg will cancel out the mole of Hg on the top. And we're going to put grams Hg on the top here. We saw it earlier is 201. Okay, and there you go. So these match, so we know we're done. So we're going to start multiplying the top numbers. So 150, you don't have to do the 1, times 2 times 201. Press enter, and then we're going to divide by the bottom number. So divide by 217. And then divide sign 2. Again, that 1 is not going to change anything. So you get about 138.9. We'll say 139. We'll round that. So 139 grams. Okay, let's do one more. Do number 5 here. 32 grams of oxygen. And we want to figure out how many grams of mercury oxide are going to be reacted in this product, in this reaction. Okay, so this is going to be a 3-step problem like the one before. Okay, so we got 32 grams O2. Again, I'm putting my unit, gram, and the substance O2. Make sure you put your units and substances in there. And we want to go to grams of HGO. Okay, so the same 3 steps as before. Molar mass of the first substance, mass on the bottom, mole on top. Mole ratio step, mole of the starting substance on the bottom, mole new substance on top. And then finally the molar mass of your new substance. 1 mole on the bottom, molar mass in the periodic table on top. So those are going to be our 3 steps. So grams O2 I want to cancel out, so I'm going to put grams O2 on the bottom. We'll figure that out in a bit, but we know that is going to have 1 mole on top. 1 mole of the same substance, O2. The mass here, we got to reference the periodic table, but we first look at oxygen. We've got 2 of them. Each oxygen has a mass of 16. So 2 times 16 is 32. So that's going to go down here. for the molar mass. Okay, grams cancels out. I'm in mole of O2. I want to get rid of the mole 2, so that's here. I want to put mole of O2 on the bottom and put mole of what we're trying to get to, mole of HGO on top. So mole O2 on the bottom, mole of the new substance that we're trying to get to, HGO on top. We need to look at the reaction here. The coefficients are the number of moles involved. So we have a 1 in front of O2 and a 2 in front of HGO. So that's going to go there. Mole O2 cancels out mole O2 on the bottom. Mole HGO does not match grams HGO yet, so we got one more step here. So this is the molar mass step of HGO. So we're going to put the 1 mole of it on the bottom and then figure out the molar mass of it on top. So 1 mole HGO, and how many grams HGO that is equal to. We actually did do that in the previous problem. So we had Hg, we have 1 of it. O, we have 1 of it. Hg, we looked up the mass, it was 201. We looked up oxygen's mass, it was 16. We added those together, and we got 217. So it'll be the same number here. Okay. All right, so these units match, so we're done setting things up. We're going to do our math here. So we're going to multiply the top numbers, 32, times 2, don't worry about the 1, so they're not going to change anything, times 217. Okay, so those are the 3 numbers we have. Enter. And then divide by the bottom numbers, which the only non-one digit number we have is 32. So divide by 32. Enter. So you get 434 grams as your answer.